In this video, I will be going over the section 6.1 day 2 notes, which is going to talk about operations on functions. And there's a whole table in your book that is found on page 385 about 4 different operations with functions. And those operations are addition, subtraction, multiplication, and division. And the biggest part for today that I want you to get behind is the notation. And it's right here. If I write, and let's say I have 2 functions, f of x and g of x, if I want to add those 2 functions together, the left-hand side is a different notation for that addition. So I think we can all get behind the fact that they're adding the functions on the right-hand side, but the left-hand side means the exact same thing. And similar for subtracting functions. So f of x minus g of x is the same thing as this notation. Same goes for multiplication and division. Basically, they are just writing the variable once instead of writing it out 2 different times. But these are the same type of operation. It's just a different notation. So, for example, for addition, if I want to take f of x plus g of x, literally all I have to do is take that 2x and then add it to the negative x plus 5. And really, it's probably better if I think about the functions using parentheses. So they're not helpful in this particular problem, but they will be in coming problems. So if I have 2x plus negative x plus 5, you just combine like terms, and you'll get x plus 5. If I want to subtract functions, this is where the parentheses really come into play. It would be 2x minus negative x plus 5. And so the parentheses are reminding you to distribute that negative sign. So this would really be 2x plus x minus 5, which is 3x minus 5. So you'll see lots of parentheses and their uses with functions in this chapter, just to distinguish between the different functions, but also to remind you of order of operations. So when I take f of x times g of x, this is just going to be distribution. So then this one would be negative 2x squared plus 10x. So you're just using distribution there. And then the last one, division. Not a lot that you can do with division sometimes if the fraction doesn't reduce. So if you wanted to, you could split up this into 2 different fractions. Actually, no, you can't do that because the denominator is a binomial, so you actually have to stay with this answer. If it was flipped around, I might be able to split it up using a common denominator, but when the denominator is a binomial, you can't split that fraction at all. So you just stop there. That's your answer. But I will say that there is a restriction, because in the last section we talked about how the denominator can't equal 0, so then x itself can't equal positive 5 for the domain. So every time you see a division problem, you're going to see a restriction to go along with it. And we know that when we're dividing, it creates these fractions, and the domain of that is restricted because the denominator can't equal 0. So today in these notes, we're just going to see a few more examples of these operations. This is very heavy on the algebra, but the most important part that I want you to understand here is the notation. So in problem number 1, I have f of x and I have g of x. So the first thing I'm going to do is find f plus g of x. So this would be x squared minus 4 plus 2x plus 1. And there's not a lot of like terms here. You can combine the negative 4 and the 1, and you will get x squared plus 2x minus 3. So I'll go ahead and then subtract them. So f minus g of x. And so make sure to distribute the negative sign for this problem. I'm not going to show the step, but make sure to distribute that negative sign here. So this would be x squared minus 2x and then minus 5. So a little bit different than the previous answer. which makes sense. It should be different. And then I'm going to multiply. So I'm going to take f times g of x. So x squared minus 4 times 2x plus 1. This is FOIL. Okay, so they want you to use FOIL for this problem. So this would be 2x to the third plus x squared minus 8x minus 4. And make sure to write that in standard form. All of these should be written out in standard form. But there's no other like terms there. So I'm done. I don't have to combine anything. And then the last part is division, f divided by g of x. So this would be x squared minus 4 divided by 2x plus 1. And once again, that denominator is a binomial, so you can't split anything up necessarily. I would just leave it just like this. But the one thing that you'll want to find here is the restriction. So say that 2x plus 1 can't equal 0, so then x cannot be negative 1/2. But make sure to find that restriction. So that is the front side of the notes. I think we just have a little bit more here on the back side, so we'll get to that now. All right, so for problem number 2, very similar idea here. So here's f plus g of x. So x squared minus 4 plus 2x squared minus 3x plus 1. Combine like terms, that should be 3x squared, and then minus 3x, and then minus 3. Just combining like terms. Going to subtract. So x squared minus 4 minus 2x squared minus 3x plus 1. Make sure here to distribute that negative sign into the second set. So this one will be negative x squared plus 3x, and then minus 5. And then I've got multiplication, so f times g of x. This is going to be FOIL as well. It's just going to be more steps than what we're used to doing because it is a binomial times a trinomial. So I'll actually show each of my steps here. So this would be 2x to the fourth minus 3x to the third plus x squared, and then minus 8x squared plus 12x minus 4, which gives me, in standard form, 2x to the fourth minus 3x to the third minus 7x squared plus 12x minus 4. But nothing really new here that you haven't seen before in terms of the algebra. And then the last one, the division. All right, so you're just going to write it as a fraction. And then you're going to find the restrictions from the denominator. So that would be 2x squared minus 3x plus 1 cannot equal 0. And that is going to take us to factoring. So 2x minus 1, x minus 1. So that means x cannot be 1/2, nor can it be positive 1. So to save a little bit of time here, the next problem is going to be very similar, but there is one note that I want to make for number 3. I'm not going to work out the whole thing, and you really don't need to either, unless you want the extra practice. But I do want to note something about the last part, the division part. So just to let you know, if you add these together, that answer would be 4x squared minus 4x minus 1. So if you want to go back and try these on your own, you certainly can. The subtraction would be 2x squared plus 4x minus 3. the multiplication is going to involve FOIL again. So it would be, as a final answer, 3x to the 4th minus 12x to the 3rd plus x squared plus 8x minus 2. But I do want to talk about the division part down here. So f divided by g of x is equal to 3x squared minus 2 over x squared minus 4x plus 1. So, I would leave this here as my final answer, but the restrictions would be x squared minus 4x plus 1 can't equal 0. And unfortunately, unlike anything that we've seen today, this one does not factor. There are no factors of 1 that add up to -4. So you have two choices here to find the restrictions, and it's really up to you. I have a preference, but you can either complete the square to solve, or you can use quadratic formula to find those restrictions. I mean, I like quadratic formula better, but it's totally up to you. So if I want to find the restrictions, I would use quadratic formula. And just to let you know, quadratic formula, I guess I'll write it over here. So that's the opposite b plus or minus the square root of b squared minus 4ac all over 2a. So I went ahead and did the opposite b and the 2a. Now I'm going to do the discriminant using my calculator. So that would be, the discriminant is b squared minus 4ac 12. Okay. And we know that the square root of 12 is, so that's 4 times 3, so that's 2 root 3. And then I'm going to divide everything by 2. And actually, we're going to say that x cannot equal this because it's a restriction. So then x cannot equal, if I divide everything by 2, 2 plus or minus root 3. And you can find that same answer from completing this square as well. But if it doesn't factor, you're going to have to do something a little different there. There's your video.